So priority queue, it can be implemented by using the linked list or by using the array concept. Now we are going to see the priority queue implementation by using the linked list. So in a computer memory, the priority can be represented by using the array or the linked list. So when a priority queue is implemented using the linked list, so here the node is divided into the three parts. Okay, so the first part contains the data or information about that particular node, and second part contains the priority number. Okay, it contains the priority number of the element, and the third part contains the address. Okay, if we are using the sorted linked list, then the element with the higher priority will precedes the element with the lower priority. So highest priority will be first, and so on. So last that contains the lower priority. Okay, and lower priority number means it is a higher priority. So that is 1 has a highest priority, and here 5 has a lowest priority. So for example, here if there are two elements A and B, so where A has a priority as a 1 and B has a priority as a priority number as a 2. So here what will be performed first? A will be performed first because A has a highest priority. Okay, so the same example, when the new elements when you are doing the insertion, okay, when you are doing the insertion, uh, in a we have to traverse the entire list until we find the priority node that has a lower than the new. So for example, if you are going to try to insert the element f, okay, and the priority for this one is 4. So what it will do, it will traverse in the entire list and find the node it has a priority lower than this particular element. Okay, lower than particular element. So C is a lower than. So what it will do, it will insert the new node here. Okay, it will insert the new node here. And one more thing, so from the queue we cannot make out whether here in this queue we cannot make out whether A was inserted before E, whether E joined the queue before the A, because the list is not sorted based on the first come first serve. So here the list is started by using the priority. So here the elements with the highest priority come before the element with the lowest priority, and we can definitely say C can be inserted in the queue before the D. Okay, because when two elements, okay, so for example here the for C it is 5. Okay, priority is 5. So here we can understand, we know that C is inserted before the D. Why? Because when one particular when one particular node have a same priority, that is what it will do, it will work in the principle of first come first serve principle. Okay, it will work in the concept of first come first serve. So with this you can understand D is inserted after the C. Okay, D is inserted after the C. Then deletion, uh, when you are doing the deletion, it is also simple process. Here the first node of the list will be deleted and the data of the node will be processed first. Okay, the first node of the list will be deleted and the data of the node will be processed first. And this is the code. So here first we are declaring, so as it is a linked list we have to use the structure concept. Here you can see for other structures it contains only two members, one is the next and the data. Here the node is divided into three parts, one is data and another one is a priority. So we have to use three members, that is data, priority and the star next. And here we are assigned the value for the variable, structure variable start is equal to null, and we are declaring the variables. Okay, and the display is a function, and here we are using the option declaration. Then we are using switch case statement, so to print all the options we are using this printf statement. and this is option is for getting the switch case options. Then if you are giving the option as a 1, so it will go to the case 1, and here start is equal to insert of start. Here insert of start function is called here. So what will happen, it will go to the function definition. So here where is the function definition? Function definition for the insert of start. So this is the function definition. So here what we are doing, first we are declaring val value comma priority, then we are declaring two pointer variables, that is ptr and the p. Then for this ptr, what we are doing, we are assigning the memory by using the malloc function, and next by using the scanf statement we are getting the value for the val and prior. Then ptr tends to data is equal to value, and ptr tends to prior, assigning the value in the node. Then we are checking the condition, that is start is equal to null. If the start is equal to null means what is the meaning? The particular priority queue is empty. Okay. Or we are checking the condition PAR. So for example, I have given, for example, consider this is the node. Okay. So these are the 3 nodes in the queue. So it is divided into 3 parts. And this is the pointer. And here the values are 4 and priority is 2 here, and it is 8, the priority is 5, and this is 10, the priority is 7, and this is x. Okay, and now we are giving, I'm giving PIR is equal to I'm giving the value as the 8. Okay, so here it will check the condition. So this is the starting, this is the start point. Okay, we are checking the condition prior 8 is less than or equal to start of prior. So it will check the condition. So when it is checking the condition, what is the condition? Is false. So if any one of the condition is true means what it will do, or any one, right? If it is false means what it will do, it will print tends to next is equal to start, and start is equal to ptr. So what will happen, it is a new node is inserted and it will be added in the queue. Suppose if any both the conditions are false means what it will do, it will go to the else part. And here what we are doing, we are making this p as a start. Okay, we are making p as a start, and we are checking the condition p tends to next is not equal to null, and p tends to next is tends to priority is less than or equal to prior. So what I am doing, I am checking the condition p is a start. Now this is a start, and I am making this as a okay. So here what I am checking, p tends to next is not equal to null. P tends to next, it is not equal to null. So condition is true. And p tends to next priority. What is the priority? It is 5. I am checking the condition. 5 is less than or equal to, what is the PRI value? It is 8. So this condition is also true. If it is true means what it will do, p is equal to p tends to next. So the next node, this node become as a p. Then ptr tends to next. Okay. So what is a ptr node? Start node is a ptr node. So this is a ptr node. ptr tends to next is a p tends to next. ptr tends to next is a p tends to next. Then p tends to next is a ptr. Now we are making this as a ptr node. Then again what we have to do, again we have to check the condition. So till this condition getting false, what we have to execute it, and we have to do the insertion here. Okay, next what we are doing, suppose if we are giving the option as a 2, so it will go to the delete part. Okay, it will go to the delete, and here we are declaring the pointer, and we are checking start is equal to null. So what is the meaning? It is null means it is underflow. So that is no element is available. If it is false, it will go to the else part, and we are assigning pt is equal to start. Then delete the item. So this is the start. So the starting value will be deleted here. So ptr tends to data. So this is the ptr node. Start node is the ptr node, and it will print the deleted item. What is the value here? The deleted item is 4. Then what we are making? We are making the start nodes next as a start. We are making this as a start node, and by using the free function we are removing this. Okay, and if you are giving the option as a display 3, it is a display. So this is the display function definition. Here we are using the ptr node, and first what we are doing, we are making, so I will draw here, uh, this is the ptr node 5 6 3 8 7 10. Okay, so this is the start node, right? This is the start node, and we are making this is a ptr node, and we are checking the conditions. Start is equal to null. So the start is equal to, here start is equal to not null. So the meaning is queue is not empty. If it is null means it will print the message as the empty. Then it will print the priority queue was. Then we are checking the condition ptr tends to, ptr is not equal to null. Yes, ptr is not equal to null. So what it will do, it will print the data and the priority. So here what is the data? It is 5 and priority is 6. Then next it will execute the statement ptr is equal to ptr tends to next. So now what happened? This is the ptr node, and it will check the condition ptr is not equal to null. Yes, it is not equal to null. So inside the loop it will print the value of the data and the priority, and we are changing the ptr. Now what happened, this node is a ptr node, and again we are checking the condition ptr is not equal to null. Yes, it is not equal to null, so it will print the value 7 and the 10. And again what we are making, next node is a ptr node, there is no node, and it will check the condition, the condition is false, so it will come out of the loop. And if you press the option as a 4 means it will exit. So this is the output. First I have given the option 1 and it is inserted the value, and when I am giving the option 3 the values are printed. Okay, and for deleting, when I am giving the 2, what is happening, the deleted item is 8, so the 8 is deleted here. Okay, the 8 is deleted from the queue. So this is the procedure for code for the priority queue using the linked list.